Hello. So in this process of characterizing software engineering, I think it's interesting to discuss a very old question that people keep asking, that probably software is not a real engineering discipline and is a bit more like art. And I think that probably this is the type of discussions that have some fun, but at least they provide you some insights about what is actually the software engineering as a discipline. And so what I'm going to do is basically to start by seeing what is art, and then to see if there are some breaches, something that are similar with the development of software. Okay. So just to pick an example, I really love Sandro Botticelli. I don't know if you know his paintings. But for instance, when I look at paints like this one that I really like, the question that comes to my mind is whether Botticelli, when he start painting these, did he have the idea about what was the final result of the painting? Okay, so and this is basically a relevant question when you think about art and engineering, because actually when you start implementing the product, and notice the word implementing the product, we have a pretty good idea, or at least we really want to have a pretty good idea to avoid bad results about what should be the product. Okay? But in art, actually, I don't think it's that the way it works. In art, basically, I think that probably you have an idea, and by the process of painting, in this case, you just change, and actually the final result is just the result of the process of doing, okay? And if you remember some of my previous videos, maybe say, well, that's what you have been claiming about software, okay? So let's discuss this a little bit. So the point is whether there are this clear border between designing the system and implementing the system, and whether this is completely mixed when you do art. And the problem of mixing these things, if you think about it, is that probably you cannot reproduce. So you are not sure what's going to be the result when you start. And if you think about industrial production of artifacts, you really know what is the result. So you have very precise results. So before you start, you're going to say how much it costs, how long it's going to take, and things like that. So it's good when you do engineering, it's very good that you can foresee and you can estimate what is going to be the result. Okay? So, but to think about this, there's a distinction between that I like by Lemons, okay, Lemons and Baladi, and they discuss software in terms of three types of software systems. The first type is S systems, which the problem is formally defined. Okay, so what type of software is this one? Suppose that you want to do some software for math, okay, a math library. What characterizes this software is that before you start the implementation, you have a complete specification of the behavior. So in that sense, the result is going to be actually what is in the specification. And it's really, really engineering doing this implementation. What can get wrong? Maybe you can get a bad implementation, okay, and things fail, but it's a problem in the implementation. It's not a problem in the specification, okay? And the specification is not going to change. So that's one of the things that characterizes these systems. Okay, so in this type of software, you have a clear separation between the specification and the implementation, because during implementation, you do not change the specification. Of course, you can do better implementations because you can have a better performant implementation. Okay, but okay, it's just you have the implementation and the specification and the design of the problem. Then they describe a second type of systems called P systems, okay? And in this type of systems, basically what happens is that the problem, you cannot completely grasp the problem. So the problem, you cannot completely specify the problem. Actually, that's what happens. So since you cannot completely specify the problem, what you're going to do is you're going to define a model of the problem. And you believe that this model may solve it. Okay? And then what you're going to do is that, well, then you look at this model like a specification, and actually what you're going to do is to implement this model. So now it's a little bit different, because suppose that during implementation you may realize, you may learn that probably your model is not completely correct or doesn't completely fit the problem you want to solve. So you start having this need of having a feedback between implementation and design or specification. The last type of software system is a E-system. Okay, that is a bit like a P system, but the difference here is even stronger in the sense that the model that you create for your system becomes part of reality. So, which means is that, remember the affordances. Remember what happens, software a social system, is that by people using the system, you change the reality, you change what you are modeling. So the problem changes itself. Well, and here then you realize that actually there's no border between the problem and the solution, because as soon as you start designing and implementing the solution, is not just a problem that you are not like in the P systems that you cannot grasp and you have now a better understanding of the problem. No, your solution is actually changing the problem. So, what could be the final conclusion about this? Yes, we need to look a little bit the way we implement products in art. In some points are similar, but of course this is engineering. So you are trying to have methods, techniques, and tools that really allows you to foresee and allows you to, before you start, you know what is going to be the result. But be aware, and that's important, that is not an easy task, and it's not because it's a problem of yourself, it's a problem of the team. No, it's the problem of the problem. Okay? So if you realize this, maybe you can have a much more smart way to develop software. Okay? Because for when software engineering started a long time ago, people tried to say that probably this was a problem of our techniques. And they tried to create software development, look at software development as a very, very rigid thing. And they tried to say all the systems are S systems. Actually, it's not true. And you have P and E systems. And actually, the most interesting systems you develop are P and E systems. Okay? So that's what you need to think about. Okay, thank you.